What's up? What's up? It's your man, Jimmy Chan. All right, so now we're talking about one-to-one and inverse functions. So let's first talk about the one-to-one. So one-to-one function means that with one input, there is only one output. If it's not one-to-one, that means multiple inputs gives you only one output. So you're like, wait a minute, wasn't when we talked about if it's a function or not, that we talked about one input, two outputs makes it not a function, kind of like food poisoning, right? Food poisoning is where you eat one food and you end up having two outputs, right? This actually happened to me. So I ate at Ruby Tuesdays, and then what happened was a few hours later, it was coming out of me in two different places, right? I got sick and I had diarrhea. So that is considered food poisoning. So therefore my body was no longer functioning. So that's why not a function. But one-to-one is a little bit different. All right. We'll get into a little bit how one-to-one really relates to if it's a function or not. All right. So with the one-to-one, so with a function, we have the vertical line test, where with one-to-one, we have the horizontal line test. Well, again, they are related. How are they related? Here it is. If a function is one-to-one, so if a graph is one-to-one, and it passes the horizontal line test, then its inverse will pass the vertical line test. That means the inverse would be a function. All right, so again, if it's one-to-one, that means the inverse of that function will also be a function. Okay, so if it's not one-to-one, that means the inverse will fail or would not be a function, which will fail the vertical line test. So that's what this next line says. If a function is not one-to-one, it fails the vertical line test. Therefore, its inverse will also fail the vertical line test. So the inverse is no longer a function. Okay. So I'll show you guys that as we move on here so that you guys can see the difference. Well, actually, you know what? Let's do it this way. No, let's talk about inverse first, and then we'll come back to it. So how do I find inverse so I can check these horizontal line tests and everything else? So to find the inverse of a function, well, first of all, inverse of a function denotes this. So if we were given f of x, then the inverse will be f negative 1 of x. Okay, so this is the original. This will be the inverse. Okie dokie. All right, so if we're given points, we just have to switch to x and y. If we're given a graph, same thing. You can pick out points on the graph and then switch to x and y and plot those down. If it's having to find composite of each other, what you have to do is find f composite g of x, and most likely this would be given in two equations, right? So let me break that down here. Don't like that rating. There we go. So given two, I'll just put down equations. F of x and g of x. Okay, so if we're given two equations and they want you to prove that these two equations are inverses of each other, you'll have to do f composite g of x, and that should come out to be x. And then if you flip them, right, g composite f of x and also get x, then they are going to be inverses of each other. So these two functions will be inverses of each other. All right. If you're given an equation, what we want to do is replace the f of x with y, switch to x and y, sounds familiar, solve for y again, and then replace the y with the inverse function. And just to remind you, because we're switching x and y, well, isn't domain all the x's, range all the y values, right? Those will also switch. So the domain of the original function will become the range of the inverse. And the range of the original will become the domain of the inverse. Okay, doke? All right, so let's get into some of these problems here. So let's say, for example, so these numbers right here denotes which one of these it would take care of, right? So I put that 1 and 2, so given points, given graph, all right? How we go switch to x and y. So if I look at this graph right here, actually these aren't supposed to be here. Let me just put those away for now. So what I was thinking about doing was, okay, so I was given a graph, right? And let's say these points weren't even here. I can read those points off the graph, right? I can pick those points and read those points off, and then I can actually write them down. As you can see, I have them right there. Well, to find the inverse, all I would do is take each point and switch the x and the y. Well, the -4 is a little bit hard to see because you're not going to see the switch here, right? But the -2, 1 you will see because there's now going to be 1, -2. You just literally switch them. Next one, 1, 2 is going to now become 2, 1. And the 3, 5 is now going to become 5, 3. Now, what I want to do is now plot those points. Let's plot -4, -4. Well, that's going to be right here. 1, -2. So 1, -2 is going to be right here. 2, 1. 2, 1 will be right here. And 5, 3. 2, 4, 5, 3 will be right here. Okay. Let's connect those points. And there it is. So now, again, here was -4, -4. This was 1, -2. This was 2, 1. And this was 5, 3. All right. So now notice how the blue is the inverse of the red. All right. Now, what was that purple line that you saw here? Well, that purple line was actually showing you the line that it actually reflects over. So this way you guys can always see, hey, did I do it right? Does it look correct, right? This line right here is called the y is equal to x, right? Y-intercept of 0, slope of 1. So if you look at it, these are mirror images of each other, of each of those points, right? So if you smack your face on the mirror, your nose is going to be right there touching your mirrored nose, right? As you walk away from the mirror, you're going to be further away. As you walk closer, you're closer. As you walk further away, you're further away, right? So they're mirror images of each other, or the reflection over the line y equals x. All right? All right. So in terms of composites of each other, so let's say we're given two functions, and there's your two functions right there, right? There's your f of x, there's your g of x. Now, what I got to do is literally do the composite of both directions and see if they equal to each other, right? So here I got to find the f of g of x. Okay, so that means I got to find f of this right here. That means whatever the f function is, right? I have to replace the x. I got to replace the x. Okay. With this right here. And I should always use parentheses, all right? Just remember that. You should always use parentheses. Okay, so let's do this. So here I can distribute this through. So let's go ahead and distribute that through. Let's bring this down here. All right. So first I'm going to distribute that through. So I'm going to have -8 parentheses. The red is now going to be what? Negative 1/8 x plus 1/8 plus 1. Okay. So what's that going to equal to? Well, that's going to equal to, now I got to distribute this negative 8 through, right? Well, what's negative 8 times 1/8? It's just going to be 1. Negative times negative is going to become a positive, so I'm going to have a 1 x minus 1 and then plus 1. All right? And what's negative 1 plus 1? Well, what I'm going to have left now is just plain old x. Okay? So there's that. Awesome. Now I got to do the same thing here, except backwards. So I got to now do g of f of x. Well, that means I got to do g of whatever f is, which is right here. Boom. So that means I got to take this g function, and wherever x is, I'm going to replace it with this. Okay. So what do I do with this? So let's go and bring this over here. So first thing, of course, I can add like terms in here. So what does that give me? Well, that's going to give me negative 1/8 times, this gives me 0, so I'm left with just a negative 8 x, right? So what is negative 1/8 times negative 8? Well, that's going to give me just an x left. There it goes. So notice how this is equal to x, this is equal to x. Therefore, f of x and g of x are inverses of each other. Okay? That's the reason why. Okey-doke. Now, again, that is for number 3 up here, which number 3 says composite of each other. Okay? Now, it says number 4, given an equation. So I'm given the equation. Now, sometimes you're going to see this. All right? And I'm going to explain to you why you're going to see this, right? Because this, I should know that the parent function is a parabola shifted up 8. But this only allows me the right half of the parabola, no left half, okay? Because this is supposed to look like this, right? Except it's saying, no, no, no. I don't want any negatives. I only want the positive x values. So it kind of cuts this off right there. So that is actually my graph right there. Okay, that's what this is doing. And why is it doing that? Is because it knows that this is going to fail the vertical line test. Okay, because it's going to meet it twice. Which means that inverse will fail the vertical line test. So if this function fails the horizontal line test, this inverse will fail the vertical line test, okay? And of course, we will get into it, don't worry. All right, so if we're given an equation, if I follow the steps correctly, and I call those steps A, B, C, D, so that's why I'm using A, B, C, D's here. The first step is to replace the f of x with y. So y is equal to this. Step 2, or step B, is to switch the x and y. Like literally switch the letters. Oops. I'm supposed to switch the letters. I didn't switch the letters. There we go. I actually supposed to just switch the letters, x and y. Now, part C is, okay, solve for y. So I got to get the y by itself now. All right? So if I had this, how do I get the y by itself? Well, I got to subtract the 8 over. And I gotta take the square root of both sides, right? So and anytime you take the square root, you have to do the plus and minus. Now, you gotta be careful with this. And the reason why you gotta be careful with it is because, again, notice what this is saying. It's saying no negative x values, which means in this case, this would go away, the negative side. Okay. Now that I got that part done, and here's the thing. If you guys ever graph the plus and minus, you'll see which part of it needs to kind of go away. And I'll show you in just a second as well. All right. Now, part D says to replace the y with f negative 1 of x. And that's going to equal to the square root of x minus 8. And that will be my inverse function. There it is. Okay. So, with that being said, all right. Now, the next example, I'm going to actually find the domain and range for this exact equation. Okay. So that's why I put down 4 and 5 right here, is for that reason. So if I was to graph this, what this says right here, right? Remember I said it cut off the negative x values. So it's only going to be this part. All right. So again, this part over here got cut off because of the x greater than or equal to 0. Okay, so because of the x is greater than or equal to 0, it cuts off all of this. Okay, so it's just left on that side. So what is the domain of this right here? Well, the domain is all the x values. So it's starting from 0 and it goes to infinity because this keeps on going up, 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 up. In fact, we're given the domain. So that's going to be x is greater than or equal to 0. Another way of writing that is square bracket 0, comma, going to infinity, right? We can write it that way as well. Okay, how about the range, the y value? Well, if you look at the y value here, it starts right here and it goes up forever, right? So it's just going to keep on climbing, but it starts at 8. So the range will go from 8 all the way to positive infinity, all right? Now remember that from all the previous examples, couple of things, right? Number one, the inverse is supposed to reflect over this line here of y equals x. Right? And the other part of it is that we could just take points and switch to x and y. So let's take a couple of points here. So, are you okay? So let's use this. So this point right here is what? 0, 8. The inverse of that would be flipping the x and y. So it will now be 8, 0. Right? Let's take this point right here. This point right here would be what? 4, 2, 4, 6, 8, 10, 12, 14, 16. So this would be 16. So now, if I flip it, it will be 16, 4. So let's see here. 8, 10, 12, 14, 16, 4, 2, 4. So it's going to be right here. So it's going to be come on. There we go. So it's supposed to look something like this, especially if this piece was right here, right? But because that piece isn't there, it's the reason why this piece here wouldn't be here either. Right? So that's the reason why the negative values wouldn't occur, because you could say, wait a minute, but this is telling me that I only have positive y values, not necessarily negative x values, but positive y values. But you're right. But if you look at the graph, look at this. If I was to reflect this over this line, which is y equals x, then I'm only going to see this. I'm not going to see this extra part that I've already lost, all right? So that is the main thing, is that you're only going to see the positive y values, and that's the reason. Now, again, if this was here, right, then look at this. This would fail the horizontal line test, right, because it would meet twice there. See that? So if that piece was there, that means this piece would be here as well. Oops. Hopefully not that way. It's going to look something like this, right? So which this piece, the inverse, would fail the vertical line test, which back in the day we would say that's not a function, right? So there it is. That's the reason why you see things like this right here, because it knows that the inverse, it wants it to be a function, so therefore it keeps it, all right? So now it will say these things so that when I was to graph it, it would take all of this away. So that I don't have to worry about it, because it would take also all of this away. Whoa, how did it take that away? That's interesting. Okay, so it'll take that away. So now this would pass a horizontal line test, and this will also pass the horizontal line test. Okay, all right, let's see here. Now, to finish this problem, this tells me the domain is this. Now, if you look at the domain of this, which is all the x values, notice where it starts. It starts at 8 and goes to infinity. So if you look at this domain is the range of the original. Notice that? And guess what the range is going to be? The range is now going to be the domain of the original. And there you go. All right. Okay. We have another example here, which was given a graph. So same thing. Most of the times you're not gonna see things like this, right? You're not gonna see these points here. But here's the thing. If you actually, let me even erase these parts right here. You're gonna see something smooth like this. Okay? So if you were to look at that, what you guys can see is that, you know, you see a smooth curve, so you're kind of freaking out going, I don't know how to do this. Well, first of all, you can, because you can read that point, and that point, and you can name those points as well. If you can name those points, that means I can name the inverse of those points, right? So if I look at 6, 4, if I take the inverse of it, that will now be 4, 6. If I take the inverse of negative 1, 2, now it's going to be 2, negative 1. And now that I look at negative 4, negative 6, that's now going to be negative 6, negative 4. Okay? So let's plot those points, right? Let's plot those points. Negative 6, negative 4 is now going to be 2, 4, 6. Negative 4 is going to be right here. So that is this piece right there. All right. And then I have 2, negative 1. There's that. So this piece right here is now that piece right there. And I got 4, 6. So let's plot 4, 6, 2, 4, 2, 4, 6. All right, which is this piece right here. Boom. All right. So now, if I take this, and graph this, try to nail the same point here if I can. All right, so there we go. So as you guys can see, when I plot that, now I have the inverse. Now, ultimate test. Let's take the line y equals x. Actually, before I do that, let's do this. Okay, so the question now is, does that look like a reflection over the line y equals x? And the answer is yes, it does. It totally does, right? So then it confirms that I do have the inverse, okay? And if you notice, the red would pass the horizontal line test, while the blue would also pass the vertical line test. I hope this helps. If there's any questions, please let me know. See ya. Bye.